Mike Langdon from Juniper Networks, although really spend most of my time doing Contrail and OpenContrail, so I kind of have two hats, my corporate hat and my OpenContrail hat. So today I'm talking about OpenContrail. So just a quick survey, how many people have actually heard of OpenContrail? Oh, more than I thought, that's good. So then I guess I'll dive right into it. So in order to kind of explain what we're doing in OpenContrail relative to networking services for Kubernetes and Docker and containers and VMs and bare metal and OpenStack and all that kind of stuff, I want to actually kind of provide a basis for what Contrail is, and then we'll talk more specifically about what that means for containers, Docker, and Kubernetes in general. Quick introduction. Then we'll talk about Docker and then Docker into Kubernetes, a couple of examples, and then just some pointers to where you can get some more information. So kind of just want to introduce the topic. So if it's of interest to you guys, that you can go to opencontrail.org and go into gory detail of all kinds of things. So OpenContrail as a basis has a few premises. And so the first of being that it's a bit of software to provide networking services to tie workloads together of all shapes and sizes. And one of the things that we decided to do back in 2012 when we started this was that it was going to be open source. So we've been doing all of the development in open source, so everything's on GitHub. So those of you who have looked at it, I'm sure have found it. And the reason we do that is for the same reason a lot of other people do open source projects, right? In particular, we had a lot of customers, or at the time, and still do, that transparency was a big deal for them. But there's a couple of things that, and I usually have a slide in the front that kind of talks about a one-liner, describes Contrail, which is a workload and orchestration system, orchestration agnostic networking system, right? So we want to provide a networking abstraction that, independent of the workload type and the orchestration system type, that you can tie things together. And do it as a set of logical objects, right, that don't tie you and bind you to the physical infrastructure itself, right? Because for us, the notion of a virtual network isn't bound to a physical router or switch or anything like that. A network is a thing that can be extended across physical domains. So I can have the same network in data center 1, 2, and 3, and extend that network into other places like that. And the way we're doing that is part of the heritage of some of the people who started writing this code were a bunch of netheads, right, that wrote BGP and routing protocols for your traditional network operating systems for many years, and said, it'd be really cool if we can actually extend these services all the way out into the compute node, right? Because they solve a lot of problems, and we've been doing this a while. And we've gotten pretty good at getting the code to be stable. So the notion for us on what a virtual network is actually a BGP signaled VPN. So for a lot of people, VPN means the thing I get from my WAN provider, right, that allows me to connect my enterprise so that it goes across their infrastructure, but to me it's private, right? But if you think about it, a VPN, it's just a closed user group, right? So you can call it a LAN, you can call it a VLAN, you can call it a virtual network, you can call it a VPN, it's all the same thing. And the reason we use BGP is because we can provide both layer 2 and layer 3 networking services at the same time, right? Because we can signal different network types. So we can forward based on MACs, we can forward based on IPs. We clearly, as an organization that wants to provide networking services, we much prefer doing stuff at layer 3 because it's a much richer environment. And it actually plays quite nicely into what you do with Kubernetes, right? Because we don't expose a service, right? It's based on things that you need in the 5-tuple, right? And the other thing that we wanted to do with the solution is that we wanted to kind of break apart a networking topology in a way that gives you a set of Legos, right? So if you take a network and kind of break it up, what are the big building blocks for that, right? You have a network, I need policy so I can associate one network with another network and what the rules are. And typically in network topologies, you stick services between those networks, right? Things like firewalls, NATs, load balancers, proxies, whatever, right? So you can kind of break down the network into those basic components. And if you do that, you can reassemble those Legos in a number of different ways to service a bunch of different things. Not only different orchestration types, but different use cases, right? And for us, you know, the network needs to go wherever compute resource is, right? And there are people who are deploying using this stuff in a way that, you know, a CPE is the compute. A data center is a POP, right? So compute is not sitting in your traditional location anymore. It's not your traditional data center, right? So if you have an AT&T, right, they're deploying 2,000 POPs with servers in every one of them, right? But they wanted to run it as one logical entity so they can move their compute resources around but not change the logical construct of the network topology they're defining for that application, right? And it's the application requirements that are driving this. So the application, even, you know, you'll do like a web server and a database, right? And for us, we would make that as two networks, and we define a policy between those two networks that says how I want my web tier and my database to communicate. Now, if you then apply that to Kubernetes, right, is my network for my web is with a pod, and we will extend the number of pods, and we'll still call it the same virtual network. And we'll get into that in a little bit. And then the flip side of that same coin, which a lot of people tend to forget about when they're racing down the hill trying to solve all these kind of network problems, is somebody actually has to run the infrastructure, and they have to debug it. And so for us, in Contrail, we wanted to make sure that we not only do the plumbing, but we get the information out of the plumbing so that you can actually operate the infrastructure, right? So analytics is a pretty important component to all this as well.
One question on the analytics. Does that go down to like the physical hardware level as well? So you can tell like this switchboard has this level of drops, or what sort of level is that?
It can, right? So we did it initially, mostly in the context. There's a component that will run down the compute node, which is called vRouter. So you would, that would be a replacement for either Linux Bridge or vSwitch or something like that, right? So that is not only the enforcement point, it's also a measurement point. So we get all the stats. So we have stats on all the flows in context, right? So when a flow goes from point A to point B, it is part of a virtual network, which is part of a tenant, which is part of a domain. And we keep track of all of that.
And do you have tools that allow you to tap any of those?
Yep.
Okay.
Yeah, so this is where things like service chains come into consideration, right? So service chains are in-band in the sense that traffic will go through some function to get to you. Or I can say, I'm going to send traffic from you, but I'll make a copy of that and send it someplace else. Right? So one of the tools that we actually include as part to kind of show people what you can do is I want to do a distributed protocol analyzer. So we launch Wireshark as a VMware container. We map that to a virtual network, and then we define some policy that says, I want to look at this traffic, make a copy of that packet, put it on this virtual network, and then the Wireshark can do it. But what's nice about it is that it's one instance of that. And when I look at the actual flow, packet by packet in the Wireshark output, it's actually coming from different compute nodes, right? So you can be very specific on what you're asking for, down to, I want to look at this flow between these two IPs or something like that.
Cool.
Yep.
Thanks.
And then the last one is we needed to build something that could scale, right? So we took some of the things that we knew under pretty well on how to make things like the internet scale. So things like route reflectors and how you get control planes to scale and be reliable and those kinds of things. Take those methods and apply it in this environment as well. So I'm not going to spend all the time on this slide. I just wanted to kind of explain that even though we're going to talk about one specific topic today, what we've designed Contrail to do is to serve many, many different use cases, right? Because if you go down, you kind of break down all the different use cases, it all comes back to a network, a policy, services, and a gateway. All right? And then as long as I have BGP, in this case, to federate connectivity, I can stretch these entities across physical domains, right? Whether it's private clouds, private public clouds. And the thing that we're seeing happen over the period of time is that the definition of what the infrastructure needs to provide is going further and further back into the application development part of the delivery of the app, right? And the abstractions are going to get even higher. And so instead of saying, I need network X, Y, X, ABC, or anything like that, what you're going to probably start seeing is that I want to apply a cost structure. I want to apply a user experience measure. I want to support the following scale. These are my failure modes that I'll accept or not. This is the SLA, right? So those are the things that people write in the app. And the product guy who's saying, go do this stuff, understand, is all these constraints, right? The infrastructure then should then infer from that, right? So if you kind of look down the road a bit, right, the abstractions are going to get even stronger. And part of that is not only the ability to say, I don't change the construct of my logical topology, but the physical location of things will move, right? And then, of course, you need the analytics to kind of look at all that and make sure it's happening the way you want. So it's open source, follow the same methodology as everybody else. It's in GitHub. We use Launchpad for bugs and features and blueprints. There's an advisory board for OpenContrail. It's made up of customers and partners. This is constantly changing. We have user groups that meet on occasion. Historically, they've been kind of coinciding with OpenStack summits. In fact, we just had a small one recently at OpenStack East here a few weeks ago. So next one will be in Barcelona. The one after that will be in Boston. My hope is that we will be doing those types of things much more often. KubeCon would be a nice place to do some of these things, and more general meetups in general. Like I said, if you want more information, go to opencontrail.org. Architecture, blog entries. Do a search on OpenContrail and Kubernetes. There's several blog entries on the initial implementations of what we're doing. There's a bunch of code hardening that's happening right now. So you can probably follow along as things start getting committed around Kubernetes. So there's a lot of work going on there. Kubernetes, and then as a corollary to that, things like OpenShift and such. So for me, there's a couple primary value propositions for OpenContrail in general. The first being that is distributed forwarding, right? So where we can, we don't want to have to gateway through something for services. So if I can have an ingress device send traffic directly to an egress device without having to go through an intermediary gateway to decide you're on network 1, network 2, right? If we can minimize the amount of tromboning that you have inside an infrastructure, it's generally a good thing. We generally don't like to incur services that require separate systems to be implemented for both two reasons that are generally a problem, right? One is congestion, and it's something else you have to manage for failure, right? So having, in doing this, it also makes it a lot easier such that if I have a workload move from point A to point B, and I always had to go through a gateway that was over here, I have to go here, and now my characteristics of my performance may change quite drastically because of that. Now, if I move my workload from point A to point B, and I don't have to go through that gateway, now all traffic will go directly to that new point, right? From all the places that I need to send it. So there's kind of two models the way that you can kind of describe Contrail as. So one thing to kind of keep it in your head that kind of makes sense for a lot of people is think of this as one hugely distributed router where the controller, the Contrail controller, is sitting as a logical, it's logically centralized in the middle, and then you have all these forwarding points. And the forwarding points are like line cards in a router, right? You program them. And once they're programmed, packets will come in, they do a lookup, it says to do some action, and the traffic will go or not go if there's no routing entry to say to do something, right? So there's a couple other things to kind of describe Contrail that I think are fairly important. So there's this debate between whether you do things in an overlay or not in an overlay. So Contrail is designed to be an overlay. And that's not to say that because it's an overlay, it can't work with things that's in the underlay, right? Because we can do both layer 3 and it's working with protocols that are readily available with most networking equipment, I can gateway through to the underlay, to the overlay back, so I can mix and match different workloads and different technologies. The other thing that we're doing with an overlay is that, and it's kind of something we learned working on wide area networks for long periods of time, especially MPLS backbones, is that there's a lot of value actually in decoupling your physical infrastructure and your logical topology. So for example, I'll use the WAN as an example, is that I can build a VPN on a WAN, right? And I can say I have an L3 VPN. I don't have to change the definition of how I deliver that VPN just because I want to do traffic engineering in the core. So I can change the technologies there without having to go back and redefine how I deliver networking services for my tenants. Vice versa, I can change how I deliver networking services for my tenants and not have any direct impacts or have to make sure that every box in the path supports my needs, right? So if it doesn't, then I can't actually deliver those functions to my customer or the tenant. So the decoupling is actually quite handy, just from an operational point of view. And the other component to that is if I have this decoupling, right, a logical network doesn't change just because I have failures. Right, I can things fail in the middle, right? So the WAN again, right? I can have half my backbone fail, traffic will route around it. My logical topology for my VPN is still the same, right? And we want this kind of thing for this type of environment as well. And then the other stuff's kind of motherhood and apple pie. You want MAC and IP addresses completely private. You want to isolate failures from one tenant to another tenant, right? So all these things are kept separate. So now the evolution of Contrail as it pertains to containers. So when we started on this journey 3 or 4 years ago now, the initial support was for KVM and VMs. But what was nice about the architecture with Contrail is that we could then easily extend it to other workload types, right? For us, because we're connecting a port, right? And on KVM with a VM, a port is tap, right? And I take this port, I associate it with a lookup table, and stuff should happen properly. Now, the only thing that's really changing when I start talking about containers and bare metal, right, is it's not a tap anymore, it's a VETH. And if it's something that's a physical, it's a logical or physical port, right? But I can still map that into a lookup table. Right? So it's just the construct of the mechanics on how I map stuff into the table, right? And you'll see that what we do with containers is that when the container gets launched, it's mapped into the bridge, and then we have a script that'll take that and remap, and we'll create VETHs, and we'll connect one side of the VETH to the V router, and the other side actually belongs to the container.
Are some of the new Intel NICs providing support for virtual Ethernets, like directly in the card? Well, there's some new feature that they're starting to offer.
So there's a couple things in general when it comes to Intel, right, and compute, right? Which actually the network, you wouldn't think it needs to deal with it, but it actually does. It has impacts on how you can or cannot map connectivity, right? So, and mostly it's because people want to drive performance for the workloads, right? So things like DPDK, SRLV, right? DPDK is pretty straightforward, but you still need to account for it in your implementation, which we do, which gets you to a certain performance. SRLV gets you another performance, but essentially bypasses everything, right? So in that case, and we have some partners who've been public about this, so Metronome is actually written vRouter into the NIC, right? So as people are going to refresh on NICs in general, if I had to guess, 3 years from now, most servers are going to ship with smart NICs, right? It's just where the NIC vendors are going. They want a little slice of that. I can't imagine them not doing it, right? And the price of that's going to come down, and just co-processing in general, right? People are going to put more cards into the servers to offload the main processor, right? I mean, that's
the network functional.
Yeah, I can think.
Make smarter NICs.
Yeah, I can think of a video card company that's been very happy about that, right? Right, and I think that trend will just continue, right? And the NIC cards will be the same, right? So you'll see, and if you look at the packet performance changes, right? So if you look at a VirtIO type drivers, right? You're limited by what? 800 to 900,000 packets per second. You go move router into the NIC, you're at 20 million, right? So it's fairly significant. So like I said, we did our initial implementation just supporting Docker. We've had that actually in code for quite some time. And then Docker networking with or without OpenStack, where net equals none. And then a gentleman named Pedro Marx, who was one of the founders of Contrail, was bored on a weekend and knocked out an implementation for Contrail networking with Kubernetes, and which I'll talk about very quickly on the next couple of slides. And like I said, we're paying attention very closely to everything that's going on. And as you said, if you blink, you miss something. So if something happens and you guys want us to take a look at it, we try to pay attention, but we don't see everything either. And just say, hey, there's some cool stuff going on, we should take a look at it. But we're spending a lot of time with Kubernetes, Docker, Mesos right now. And I said, other stuff's going on. So what are those Legos? And these are actually 3 of the 4 Legos, and I'll talk about services in a few minutes. So the first one is a virtual network. And for Kubernetes, we'll map essentially the label for the name into that. We'll infer the networking based on the relationships of things within the application you're trying to define, right? So I know there's a bunch of things going on as far as modifying that a little bit. But actually, if you take a look at the way we've done it, I think there's quite a bit of value in the simplicity of it, right? So if we can infer networking based on what you want to do with the application, it actually makes it a lot easier, because then the person who's writing the manifest doesn't have to think about it so much. If you start having to include these things in the manifest, that means somebody has to think about it, which means they may think of it wrong or forget something or something like that, right? So like I said, the part of what we did with networking is we wanted to provide an abstraction such that we give you very simple building blocks. So the networking can be inferred by what you intend. At least that's the goal. The next one is a network policy, which essentially maps to a use, right? So if you have a name that says use this, then we'll say, well, then this stuff needs to talk to this. We're going to make a policy within Contrail to let these things two talk. And then the last thing is a gateway. So how do I connect the virtual world to the physical world? So in the context of Contrail, this is a VPN. This is effectively a VPN. The things that make the virtual network unique in the context of Contrail is because we're using BGP, the way you uniquely identify our virtual networks through an attribute called a route target, right? And the space that I have within the route target is on the order of millions, right? So defining lots and lots and lots of virtual networks is not a big deal. And it's that very attribute that allows me to define how I want things to talk, right? So when I talk about policy, policy actually has to have 2 things. One, it has to have some rules about reachability, and then it has to have rules about access, right? So the reach is the forwarding elements need to know who the next hop is or where that thing you're trying to talk to is. And then the second thing is on what protocol port do I need to talk to that, and am I allowed? Right? So all of that is inferred through the definition of the application, and we will build the associated policies with that. And then when the traffic is going, you can see the policies and you can see the traffic against those policies. So if you have traffic that's trying to move within the infrastructure that doesn't match any of those policies, you'll see the flows being recorded with 0 packet counts. So one of the things I actually show for debug purposes is that when people launch stuff, that you actually see the traffic trying to go somewhere, even though it's not allowed. So, because people write code that tries to open up ports to places it's not supposed to, right? You don't know that unless you have something that's actually looking at that traffic, right? So this is why I was saying analytics is pretty important. And so, from a policy point of view, right, I have to import routes from red to green and from green to red. And we're just saying anything with the attributes for red routes, I want to import all those routes that have that same attribute in green. So now if I do a lookup over here in green, it knows how to get to something in red. The secondary check is, what protocol and port am I sending stuff to, right? And so you're defining your relationships within Kubernetes based on that. And so if you have something in here that's going to talk to this, then that rule will also be applied.
Are you automatically creating that policy and through the event?
Yeah, so like I said, so we're inferring that from what you're putting in your manifest for the application.
So any services that deployment needs to connect to, or any bindings between any of those?
Yep. Yeah. So where we're creating the pods, we'll create the networks. And then when you reference the connectivity between a pod and a use, then for us, that effectively is a policy, right? But we're inferring that from how you want the relationships within the application to be. And then we're building the network to reflect that, right? As a logical abstraction, right? And this next one, which is something we do natively within Contrail, is this notion of service chains. Right? So when we talk about how I want things to go between green and red, in addition to saying, I want to send traffic from here on this protocol and port, is I can say, in addition to that, I want it to go through these functions. And you can put it n number of functions. You can reorder the functions on the fly. And we will build the networking between these hops wherever they are. And these, again, could be physical or virtual. So if you want to start putting functions, let's say, between your web and your SQL server and have a firewall there, then you can, right? Because that's already built as part of the construct that we provide. The way this is going to go eventually as well is most people are doing service chains that are linear, is that over time, you're going to start to see it's going to get much more complex because we're already seeing as people have initially rolled out their initial services, is that these are going to go from linear to graph-based services. So in other words, services that branch. In other words, I have to have a service topology that's actually a tree. Right? And so getting the routing and the networking connectivity correct for that is just going to get harder. Right? So one of the things that Contrail is doing for you is it has a visualization of what that topology needs to be logically, and then it maps that logical topology against where entities within that topology physically are located, and then actually building the networking between those entities to reflect the logical construct of the topology you want. Question?
Security for this? If you want to secure everything, somebody can outside one side to myself in another.
Yeah. So, I mean, one of the things, so Contrail is technically part of your infrastructure underlay, right? So the only thing that gets exposed to the outside is not really anything with Contrail. It's the logical topology, which is advertised as BGP routes to your gateways and your traditional networking gear, right? So to your gateway router, it's just talking to Contrail, and it thinks Contrail is a route reflector, right? And typically that stuff is not exposed to the outside anyway. But now if you want to provide security, and then you can build your infrastructure security anyway. But then on top of that, if you want to build security into your tenant topology, then you can add things like this into it as well. Including things like, I want stuff in here to go out to the outside world, so I'm going to build another virtual network where one of these VMs is actually an IPsec gateway. And I'll have the IPsec gateway control say, even though that's a static connection, whatever IP address that IPsec gateway got, I'm going to tell the rest of the world to advertise that as the default gateway into this virtual network. So there's all kinds of things you can do. The other thing is that, like I said, it comes back to the analytics, right? You have to know where the traffic went, and you have to have a record of it before you can know if you need to do something else. So again, this is kind of what you want to do, right? And with any orchestration system, essentially you want to say what it is you want, and for networking it's the same thing, right? I want to describe it, the network, essentially in these ways. Now, in the case of Kubernetes, right, we're inferring this topology based on the relationship of the application components that you have. But under the covers is effectively what we're building. So for example, if I look at Docker container, and it gets booted, and it originally gets mapped to the bridge, what will happen is it will get remapped with a veth, where one side of the veth is on the vRouter, and the vRouter will have many forwarding tables, one for each virtual network. And there's one vRouter per server. So it's not one vRouter, many vRouters in one, where you would have to have one per tenant or anything like that. And then what happens is this vRouter will tell the control plane that I am the IP next hop for this destination, and in order for everybody else to send traffic to this guy so that he demucks that traffic into the right lookup table, is I'll bind that to a particular label. Now that's not a Kubernetes, that's a VPN label, MPLS label. Now the thing to consider is that I'm using the MPLS label to allow me to mux and demux traffic to a lookup table, the same way that you would use a VLAN tag or anything like that. I need to put some sort of tag on that packet, so when the receiver gets it, I can make some sort of association of where it belongs. Otherwise, I have no idea, right? The MPLS label does the same thing. Now, to go from server to server, it's just IP, right? If in a WAN, if I'm doing an MPLS backbone, my tunnel, instead of being IP, would be an LSP, right? It's just a different tunnel type. And inside the data center, it would just be IP tunnels. So MPLS over UDP, MPLS over GRE, or in the case if you want to mix this with the traditional layer 2, be VXLAN as well, right? And I suspect other NCAP types will come to add things like encryption and things like that. So there's nothing in the architecture that requires any kind of encapsulation type. It's just whatever the ones people want. And then when this guy advertises it to the control node, he's going to, just like a route reflector would, the control node is going to re-advertise it to every other compute node, or in the case of Kubernetes, a minion, where vRouter is also running in each one of those. It'll tell every other one that also has something that's part of that same application. And this is the thing that allows you then to both scale and provide redundancy, because typically vRouter will talk to multiple control nodes. So if I lose control node, I always have redundant control plane path. Control nodes talk to each other and share, so I can scale out control nodes so that I can add thousands of compute nodes. I think our hero test in our internal lab right now is a 2,000 node cluster, which for most people is pretty good size.
One other question. Do you allow, in this virtual network, regardless of orchestration management system, so if you're OpenStack, Docker, and Kubernetes, it all will still be able to work and talk to each other as long as you're using OpenContrail?
Yeah, I mean, so the thing that we're doing, like for example, with OpenStack, right, it's a Neutron plugin, right? In Kubernetes, we had to write a little process that's listening to the Kubernetes APIs, and then based on those APIs saying, oh, telling the rest of Contrail, you need to go build this because this is what this guy is trying to do, right? Yeah, and then how you want to connect things. So we have, and then, I mean, if you want to, you could throw all of that away and build something custom and talk directly to the APIs. It doesn't, and we have people doing, there are people doing that as well, who are not using any of those things and just write directly, because It's all REST API anyway.
And they just show up as DNS names and port numbers, or IP address names and port numbers?
So generically, no, within Contrail, but that's what that additional process for Kubernetes is doing to make the relationship. Because when you go into Contrail, it understands virtual networks, policies, services, gateways, right? So the
IP addresses.
yeah, so essentially we need something to act as that schema transformer, which is the config node, but then we need something on the config node that's going to act like that plugin into the particular orchestration system, so that we can infer the right dialect, right? All right, so in Docker only. So I talked about this a little bit on the control plane. So orchestrator into Contrail for a config node. And the config node essentially is just a schema transformer, right? So it's going to get the high-level service definition from the orchestration system. It's going to convert that into something the physical networking devices can understand, right? So eventually it's going to show up as a BGP route advertisement, a provisioning statement for a router, BGP, OVSDB, or if we're going to talk to compute nodes, we'll send the provisioning information over. We're using XMPP as the control channel between the control nodes and the vRouter. But that's essentially that, right? So because we've defined the config node up here as kind of that schema transformer, we can keep adding data models as these things evolve without changing the architecture. Right? So config node is acting as a schema transformer. The control node infrastructure is acting as a distribution mechanism for that information, and then you have your forwarding elements, right? So I mean, at high level, that's pretty simple approach. Let's see what I want to say on this side. Also, from a data plane perspective, so this is a compute node. You have vRouter running in the forwarding plane. There's a kernel mode driver, and then an agent that runs in user space. And then the agent is going to talk to the Docker driver, which is going to do the remapping of the container from the bridge to a set of vs that will connect to the vRouter. I'm not going to, unfortunately, I don't have time to go into all of these, but I do encourage you again to go back to opencontrail.org to kind of look into more details on how the vRouter works. But the things that it's effectively doing is it's being a replacement for the Linux version vSwitch. It's providing both layer 2 and layer 3 VPN services. So for every virtual network, you can say it's layer 3, layer 2, or layer 2, layer 3. And for layer 3, it's either v4 or v6. And then in addition, the vRouter is providing these additional services besides what you would expect, which is forwarding. And those things are the enforcement of security policies. We do NAT, which is going to be an important function when we talk about the need, or in our case, we don't need kubeproxy. So Contrail will do that natively. The ability to do native cache replication natively within the overlay, mirroring, which we already talked about, and then the other big one is load balancing. So at the network layer, because the network, from our view, has to deal with the fact that infrastructures are elastic, and traditional networks don't do real well when number of paths change. So if you look at a normal network, right, and I change the number of links between me and you, I recalculate the hash. So traffic that was going on link 1 may move to link 4. Which, if you're in the middle of a backbone, it's probably who cares. But if I have a function between me and you, like a firewall, and I moved it from instance 1 to instance 4 of that firewall, that's probably a bad thing, right? So from our standpoint, we will do load balancing to that with flow affinity in both directions, right? And so we do consistent load hashing to do that. And the vRouters will maintain state on those flows. So you can go to every router, you'll see what flows are active and what the current packet byte counts and all that kind of stuff, and which security rules applied. There's also a bunch of advanced features around this, things like health checks. being able to validate paths between point A and point B. So you can do things like primary and backup service paths. So in other words, you can say I want one to be higher pref and one lower pref by manipulating with the metrics. I can say with a health check that if a function goes away and I don't get a response, either ICMP or HTTP in some period of time, then I'm going to withdraw the route to that instance, even though just from a networking point of view, and alarm that, and somebody is going to have to go look at that instance and see why it's messed up. Right? So there's things we can do from a networking point of view to actually help from an operational point of view on the application side. And then there's a bunch of other things we can do as well from a policy perspective to do fairly advanced network topologies, hub and spoke, all those kinds of things, which when I look at people doing stuff in OpenStack traditionally, didn't really care about those things initially. But as they got into their use cases and refined their use cases and customers started using them, and they started asking questions, and I want to do this and that and the other thing, then all of a sudden all these more complex started being asked for. So if I look at what's happening now in Kubernetes, from a networking point of view, most likely those more intricate scenarios are going to start creeping in as people deploy and use and their use cases get more sophisticated. So from just a recap on Docker networking, it's pretty straightforward. Like I said, this is what we want to do. Just high-level logical networks and define policy for things to talk to each other. And from our standpoint, the ability to then mix and match workload types, right? So you can mix containers with bare metal and VMs and whatever you want. And I think that's all I want to say on this slide. All right, so let's talk a little bit about more. It must have been somebody's transition. Caught me by surprise. All right, so this slide you can barely read, so I'm going to skip it. So OpenContrail with Kubernetes, like I said, there's a few more bits we have to add in to make it work with Kubernetes. The big one being with the API server, we need to add a little process here that's going to listen to those API calls. Right? So when I get those calls, I'm going to then pass that through our config node. Right? You can almost think of this as the Neutron plugin, right? But the Kubernetes version of it. And it's going to take what it's hearing from the API server about what it needs from an application deployment point of view. It's going to pass it on to the config node. Essentially, it's going to then be converted into one of those 4 building blocks. Right? So when I create a pod, I have to create a virtual network so I can attach the pods to get IP addresses. I'm going to define a policy that says what the relationship is between a label and a use, right? And then based on those relationships, I'll build those networks, build those policies, and exchange the routing and such. When I want to expose a service out, then things like the NAT function that gets built, that's already built into Contrail, right? And so instead of employing that through the kube proxy, right? And the load balancing, so if I do replication, right? So Contrail will see all those instances, and we will do the load balancing across all the pods, right? And as the pods come and go, for whatever reason that the replication server decides to do that, right? We'll just simply reflect that the intent. Trying to think what I want to say here. I think I covered most of this already. So if I go, so this is from the data plane perspective, right? And so this is again what I was talking about before, right? So you have the bridge, and what happens is that we will map that to a V that will again take me and connect me to the V router. But other than that, the architecture is always completely the same, right? Other than there's an OpenContrail kubelet plugin that's talking. And exchanging the programming with the local vRouter agent. But other than that, all the other stuff that you would see for Docker containers is identical. It's just dealing with what needs to be inferred from a networking point of view based on how you're deploying the application in Kubernetes. Skip this one. So this is essentially what it looks like if I have to do the relationships between the two. So if I have a name over here, right, a name essentially equates to, we will create a virtual network that maps to that name, right? We will auto-assign a route target. We'll do all the stuff that's there, right? And then I'm going to assign that to a use, which is another pod, for which there's also a virtual network created, right? But because I've mapped this to a use, basically I'm saying I need this guy to talk to this guy, right? So I'm going to define policies that says that those things can talk to each other, right? So we're inferring what the network needs to be based on how the relationships you're building within the application. And this is just more of the same. Let's see if there's anything new here. No, I think I explained all this stuff already. Okay, so just to recap on it, I think the biggest things to consider is that we infer the networking directly from the definition files. Native in Contrail itself is you don't need to deal with kubeproxy because we have that directly built in, and also the load balancing is already built in, right? So all the things that you want from a replication services, the number of pods you want from Elastic, from both failures, the network will see those API calls, and we'll just adjust the network accordingly to deal with that, right? And since this is all an overlay, we don't have to go touch any physical boxes to do this, right? We're just talking to vRouter on the servers themselves. And as long as the servers have IP connectivity amongst themselves, from a host-to-host perspective, that's all that's required. Now, the underlay at that point can be anything, from a simple hub to an IP class to spine and leaf or whatever you want, right? And that's, again, the point, right, is that we don't dictate a particular physical network technology for this to work. And in fact, most people have many versions of this stuff, right? Just a couple examples. Again, most of these guys all three of these guys are very active in the community. So if anybody wants to talk to guys from Lithium, TCP Cloud, or Workday, happily do it. They're also very active on the community mailing lists. So in the case of Lithium, they're moving to cloud-native microservices, and so they're doing this as VMs on their private environment plus Amazon. And just some example of some of the stuff they're doing. IoT, smart cities, TCP Cloud. Again, a very different use case, right? The first use case was mostly a traditional data center environment with hybrid, right, data center environment. In this case, what these guys did is they're using Kubernetes to tie it to sensors that were all over. In fact, at the last OpenStack Summit, they actually had it through the whole venue, so in Austin. So it was kind of interesting, is that they were measuring the CO2 levels as people were moving around the building. So they could tell where people were congregating based on lack of oxygen. So it's kind of interesting. But so that was all built on Contrail using Kubernetes as well. And I think they actually did it on Raspberry Pis. It was pretty cool what they cranked out in, I think, a couple weeks. And then Workday is another one, right, which is a SaaS provider that's tying together all these applications and services together. And they're moving pretty quickly to Docker as well in Kubernetes. So there are some real people who are using in Contrail with this stuff. There's a lot of work going into code right now to harden Contrail for the evolving things that Kubernetes needs. So we're trying to move as fast as Kubernetes is as well for networking services. So if anybody's interested, I certainly encourage you to keep tabs on what's happening on GitHub and what's being checked in and the discussions going on, because it's actually pretty interesting stuff. Yeah, so I think I covered most of this stuff. Contrail, one of the use cases for Contrail from an orchestration point of view is Kubernetes, but it's designed and architected to support a much broader set of things, support a broader set of use cases. The one thing I tell people all the time is So whatever use case you think you're working on today, it's probably not going to be the one you're working on 3 years from now, right? And networks are hard to replace. They're just painful, period, right? So having to build, use a networking technology that hopefully can evolve with you. And so far, we've been pretty satisfied with the architecture. This is the same architecture that we started with back in 2012. And it's just evolved to cover all the things that have happened since then. But the base architecture has not changed. The 4 Legos have not changed, right? So I think we guessed pretty good. Time will tell, of course. But I think we did a pretty good job of letting this technology kind of evolve to support all these different kinds of things. And this is the one, I'll put my Juniper hat on. This is the one thing that my marketing guys asked me to put in. There's a link to a white paper that talks about Contrail networking in general, if you're interested. But like I said, go to opencontrail.org, get involved. If nothing else, read and learn a little bit about what we're doing and how we're solving the problems. Agree, disagree, but we enjoy the debate. So we like to be challenged if people don't see it the way we see it. Any questions? It's either a good sign or a bad sign. It's usually not anything in the middle. Was this helpful at all? Yeah? Question?
I'd just say a lot of people talk about, like Jiffy, right? Google infrastructure for everyone. But people kind of forget that Google did a lot of networking, right, internally. That between any 2 servers, right? They had like 10 gigabit between any servers. Mm-hmm. They built a lot of, because they put BGP on every server. And so I think this is kind of cool. A lot of people don't think about the networking infrastructure they need to support things like that.
Yeah, I mean, the one thing I'll say, right, so Pedro, who's one of the founders, he used Juniper for a long time, so he's, when it comes to routing protocols, he's probably one of the 10 best kung fu masters in the world on this stuff. And he went to Google, and he saw how they were doing stuff, right? So this is how he came up with these ideas. It was based on that experience, a networking guy's experience, and an operator's experience, right? So clearly he saw a need, right? Any other questions?
Just the fact that metrics is such an important part of network and being able to deduce what's happening. Yeah. It could be a big black box. That's a cornerstone of the.
Yeah, and sadly, it's usually an afterthought for most people, and it's painful afterthought. Right, so to me, it's 2 sides of the same coin, right? So plumbing's one side, analytics have to be the other side, because the analytics are going to feed back into the workflows and DevOps models, such that you can do things like re-optimize the infrastructure, all this stuff. You need data to do that, right? And you're starting to see that even with an OpenStack, with Worker, and some of these other projects, right? The people are starting to get interested in that stuff, and you got to do it with data.
Well, one of the things that was kind of fascinating for me is like, if anybody's ever had to wait for a network sniffer to actually be put on a network, right? Like the idea of being able to logically tap is extremely useful.
Yeah, that's the question I ask all the time. How long does it take people? And this is after I do it, and it's up and running in like 60 seconds. And it ranges from never to a long time to the guy who says, I can do it just as fast. But then they ask the questions, how many millions did you spend on that network? And he's like, yeah, well, yeah, it's dedicated and it was millions of dollars.
The hour to convince the network team that you need to put a network sniffer on it, right?
And anybody,
there's a problem.
and anybody in operations knows is that the faster you can get somebody to stop screaming at you, the better, right? All right, thank you.